Hi students, today we will discuss on motion in one dimension. I hope in class 8 we have already discussed lot of things and you will get lot of things common also over here, but bit in depth. Motion in one dimension means we will only be taking care of any body moving in a single dimension. That means we are not going to discuss on of its position along x or y. We are only concentrating on one dimension, that is either x-axis or y-axis or z-axis. Hope you remember our classes in class 8 where we have discussed taking a room as an example for 3D motions. So from that 3D means x, y, z, 3 dimensions. For 2D it is only x and y, and for when we go for one dimension, that means only one axis, either x, either y or z. Normally we will take care x-axis only. Okay, now before moving to this parts, we need to think or we need to recall our earlier classes where we have discussed on physical quantities. Physical quantities, you have fundamental, derived. Again there is also the physical quantities are also divided into again two major parts depending on magnitude and direction. So when we talk about magnitude and direction, then physical quantities comes under two categories, one scalar and the other one vector. Scalar quantity, vector quantity. If you remember our classes in class 8 where we have discussed that scalar quantity are those quantities which are only having magnitude, while for vector we have magnitude and direction. Anything more what we have discussed? Just please recall what I am telling. For scalar only requirement is magnitude. That means if a quantity is only having magnitude, we'll talk this one or we'll consider this one as scalar quantity. Vector quantity, magnitude and direction. Anything more? Anything more? If you tell me that sir, vector quantity, if anything is having magnitude and direction, it's okay sir, it is vector quantity, I'll give you full wrong. The answer is wrong. Now you tell me why. Somebody will also tell sir, it is there in the book it is written vector quantity. So for vector quantity, magnitude and direction, if any quantity is having both magnitude and direction, then it is a vector quantity. That is written in your books at very early stage, but as you come in class 9, and also I have prepared you for class 9 in class 8 only. So in class 9 when you come, be sure if you write only magnitude and direction as a prerequisites of a vector quantity, you are missing out a major point. What is that major point? To be a vector quantity, you need to have magnitude, direction, plus it should obey vector addition law. So this part is very important. Now from this position I'll ask you one question, just think of it, and in my next video or if I get some questions from there from your side, if you cannot answer that question, let me know. What type of quantity, whether scalar or vector, is your current, electricity or electric current? Which quantity, whether scalar or vector? If you tell scalar, you need to give me the reason. If you tell me vector, you need to give me proper reason. Without proper reasoning, your answer will be cancelled out. Your answer will not be valid one. So now you have understood scalar quantity, vector quantity. Scalar quantity where the quantity is only having magnitude. Vector quantity is the quantity which is having both magnitude, direction, plus in addition to all this, it should obey the vector addition law or rule. So now we will go for the next part. So we have gone through this part. Now we will go for the quantities or the terminologies for motion in one dimension. The first one will discuss about distance. and with that we will also discuss displacement. Now what is the difference between distance and displacement? Suppose you are at home and from home to our school, two students, any one of you can take two different paths. So one is going through this path and reached school. The other person also reached school by going a different or by taking a different path. That means this person has taken this path, and this person have taken this path. That means from home you can take two brothers in the same home, because I have given only single location, so afterwards don't ask her how we are located in the same house. So take it as a brother or sister, whatever you want, feel comfortable, consider it. Now say the third person, which the third friend of yours, who is also moving out from your house, but he took a straight path to school, that means if you consider all this, you will find that this is the shortest distance traveled. So that means, and also in the same direction. Now if I compare these all three paths, path 1, path 2, path 3. If you see here path 1, the directions are different at different positions. If you see this one, direction is also different, that is for path 2. Directions are all different at different points. But if you see the third path, you will see that it is moving in the same direction only, and also the shortest path. So that means the person who moved through a distance in a particular direction, that means in only one direction, that is considered as your vector quantity. That term is called displacement, where the body from H to S took the shortest path. That means this path 3, you can consider as displacement, but for path 2 and 1 both will come under distance. So that means distance is the quantity where the direction of motion is continuously changing. That means not in the same direction throughout the path, but here for displacement the direction is a single direction only throughout the journey. So that is called displacement. So hope you have understood this term, distance and displacement. So from here, since distance, direction is continuously changing, that means no particular direction, it is only having magnitude then, so this is a scalar quantity. So I am coming on this again. Since for distance continuously directions are changing, so that means direction is not a constant one. So and only the constant part is what? The magnitude, that's say 5 km, 10 km, whatever it is. So that is constant for this one, because for this path it took say 10 kilometers and for this it is 20 kilometers. In both of these cases direction is too different. I am writing it again. This total path say 10 km, I am writing it again 10 km. So that means 10 km at any directions, through any directions, 20 km also through any directions. So that means this one is your magnitude, but direction, these arrowheads are giving the directions are all different. So we are considering this one as a scalar quantity where only magnitude is valid. For displacement what is happening? For displacement, if you see here, for displacement direction is the same direction, and also if it is say 5 km, then it is having the magnitude, this is your magnitude and this is your direction D. So it is having a magnitude as well as a particular direction. So displacement is considered as a vector quantity. So this is all about distance and displacement. Now we will go through or go for your speed and velocity. Now we will go for speed and velocity. So I am writing speed over here and velocity here. Now again, if you see here, I have already written speed in place in the same line of scalar. Yes, speed is a scalar quantity, velocity is a vector quantity. Now that means it is very clear, speed is having this magnitude but no particular direction, while velocity is having magnitude as well as direction. That means if I now consider this part, speed is distance traveled by time interval, while velocity is same, the upper one is same, I will write distance traveled only, but I am rubbing this vector part, traveled in a particular direction. So in a particular direction by time interval. So everything almost remains same from speed and displacement. Only major difference is that your velocity is distance traveled in particular direction. This portion is important, in a particular direction, while that is velocity is distance traveled in a particular direction divided by the time interval, while speed is the distance traveled only, that means there is no direction involved, distance traveled, and this one is time interval. That's the same thing what we have done for displacement also. So this is all about speed and velocity. Speed is a scalar quantity. Hope you understood that this one is a vector quantity because it's in a particular direction, so it's having a direction. So any other differences? So speed and velocity are having only one is scalar, the other one is vector. Now suppose this is your east, this is your west, this is your north, this is your south. Now if you consider say a body is moving, say a car is moving, I am not much good in sketches and all, and so I have drawn only a car over here. This car is moving in east direction. In east direction the car is moving. That means what I am telling, the car is moving, okay, and also it is moving in eastward or towards east. That means I am giving a direction to it. That means if it is in a straight line path, it is moving with certain velocity. Similarly, the other car is also moving, but it is moving opposite to this one and towards west. When this car, if I consider this car as car A, the first car, and it is moving in this direction, if I consider this one as positive, hope you know that's if I go for your basics, number line, if you remember number line, plus side, minus side. If you see here, this one is going in the negative side. So you understood? That means for velocity you have plus as well as minus because it is having directions. Why? Because we have already found out that it is having direction and magnitude both. Vector quantity, so it is having direction, and if I consider, that means whenever there is a direction, if I plot this one in a x-axis or say in a line, if I try to differentiate between two movements, we can always tell that this one, if I consider this one as positive, then this is your negative. So scalar speed and velocity, there are some differences. If I write say speed over here and say velocity, then speed it's a scalar quantity, velocity it is a vector quantity. Speed is having no sign, and this one may be positive or negative. Again, there is also another thing, speed, average speed can never be 0, but this one, average velocity, can be 0. You can also write speed can never be 0. It is never. don't go for my handwriting. If you are having problem in my handwriting, I know you in class also you have understood already how I write, so it will not be a much of your problems. So average speed can never be 0, but average velocity can be 0. So average velocity can be 0. How your average velocity can be 0? Now, how velocity can be 0 but speed is not 0? Tell me one movement where velocity is 0 but speed is not 0. Tell me one condition. I know many of you will answer this one. Those who have followed my class in class 8 and 8, I know you can easily tell me the answer. Suppose there is a circular path and a body is moving from position A and coming to position A again. That means the body is moving in this direction. Started from A and ended up to A. Now in this case, if I consider the directions, each and every place the directions are different. If I consider this one, I will see each and every place the directions are different. So that means direction is different but the body is moving, correct? So that means the body is traveling some distance, with time interval but no particular direction. So that means it is having speed. So I can write it can never be 0. But for velocity, if you see velocity, what is happening? It's not, we cannot consider over here the velocity as a whole. We cannot consider as velocity. Why? Because each and every time the directions are changing. So that means we cannot tell that there is a velocity over here, first thing, because the direction is continuously changing. So the average one, that is from A to A, is always speed, it's not velocity. This is one fact. Second fact, if it starts from A and ends up to A, as I have written distance traveled in a particular direction, then this portion only, distance traveled in a particular direction, this only tells you that this one is nothing but displacement. Displacement is what? Displacement is the distance traveled in a particular direction. So that is called displacement. Displacement is distance traveled in a particular direction. So that is displacement. If you see here, the displacement is 0. The body is from A and it is at end A only. So that means the displacement is 0. So if displacement is 0 for this, then velocity obviously will be 0. So that's why I have told that average velocity can be 0. You can also write velocity is 0. Now we have learnt about speed, velocity, distance. Let us now move through some more topics like acceleration. Hope many of you have already known what is acceleration. So acceleration is nothing but the change in speed with respect to time. That means a body is moving with, say, constant. Now suppose this is a graph where this is your displacement. Displacement or distance we can write as S. Displacement we are writing as S. This is your time. Suppose a body is started from initial point O and the body is continuously, let me do it in a different color, that will be helpful for you, I know that. So say this is the motion. That means what? This is a graph. Any problem in understanding the graph? Now see here. Say this is 1 kilometer. So 1 kilometer did in 1 hour, say. Then again, so there is, say this is 2 kilometer. This is in 2 hours. That means 0 to 2 hours it is. The graph is not proper. So please have mercy on me. So 1 hour is going 1 kilometer, 2 hours is going 2 kilometers. That means what type of graph it is? How you can find out a graph? If you see here, if I take this point, say this one as say 10 kilometer and take this one 10 kilometer and say take this one as say 10 hours. I have taken just an example only. Now you are asked to find out the velocity. If you take this one, this is your del of S. That means what? 10 minus 2 kilometers. This portion is your del T, that is the time interval. From this point to this point we are considering. From this point to this point, this is his displacement, that is 10 minus 2. You will be having 8 kilometers. and from this to this, as I have told you, that slope is del v by del t, that was a displacement time graph, and this one is your del v by del t, that is velocity time graph. This velocity time graph gives you, if I find out the slope, what will be our unit, that is kilometer per hour and divided by hour. So this will give you kilometer. I am not writing the value over here, the value is same, del v by dt, v by t. So this will be coming as kilometer per hour square. If I go for meter and per second, then I would have got meter per second square. And this is a unit of what? This is a unit of acceleration. So from here we got the value or the concept of acceleration. So what is acceleration? Then in other way we can write acceleration A equal to change in velocity by time interval. So change in velocity by time interval is your acceleration. Now in this total graph, okay, let me rub this one out. I hope you have understood this part. This was your displacement time graph. If I find out the slope, I will be getting velocity over here. I am writing for this also, let me write, then velocity equal to, this was your displacement, that is del s, and this was your del t. So that is your velocity. Displacement time, displacement by time, that is kilometer per hour or meter per second. So we are getting velocity, there is a dimension or the unit of velocity. So we are getting velocity from this graph. When we consider this graph where velocity is on the y-axis plotted and time on the x-axis, here also if I find out the slope, I will be getting change in velocity, that is this one, del v this term, and del t, that means this term. So del v by del t, that is change in velocity with respect to time, or change in velocity, or you can also tell in this way, the rate of change of velocity is acceleration. So in class 8 also we have discussed on the same way, the rate of change of velocity is called acceleration, and here the rate of change of displacement is called velocity. So now let me do one thing. Let me now go in detail on a bit on acceleration, then we will be moving out to some graphical parts to find out the equations. So now let us do one thing. What we will be doing now? Acceleration part. So say acceleration, what we have got? Change in velocity by change in time. Now change in velocity, let me write v minus u, and this one as say only t. Change in time I have only written this. Now what is v and u? V is your final velocity. That means suppose you have you are moving on a road at certain point. Suppose there is a car and it is moving this direction. At this point it was having a velocity of say u, that is at position say A. Now after some time it reached over here and the position here is B. Now when we have calculated the velocity, what we have found out, that at position A the velocity was u and at position B the velocity is v. That means this, and I have taken 2 points. One is point B and there is point A. Point A where it was moving earlier, point B where I have found just now it is moving. That means is at this moment we are going to take the final velocity reading. So final v is your final velocity then, and u is your then initial velocity, and time interval I have taken just as t over here. Now if I do this equation, if I write this equation again, so A equal to v minus u by t. From here I can write this one, I can cross multiply, I can write at equal to v minus u. I can write then v equal to, if I take u over here, u plus at. This is one of the important equations of motion in one dimension. So you need to understand this part. If you are, there is nothing to memorize. I tell you repeatedly, there is nothing to memorize. If I understand this one, then from here only I can get this equation. So there is nothing to memorize. Hope you have understood how v equal to u plus at we got. Even this equation is very important. From this equation we can also take the equation for time v minus u by a. So this is another equation, but this was the most important one. This one will be used, this equation will be used to find out the other equations. So t equal to v minus u by a. Even from here I can get another equation also, that is also not too important, but that will be used to find out the equations. V minus u equal to, I can write at. So how many equations we have got over here? We have got three equations. What are those three equations? V equal to u plus at, that's the most important one. Second, we got two equations, this one, t, for time t we have got v minus u by a. This one will be used to find out small numericals, also to find out or to derive other equations. This is v minus u equal to at. This will also be required to find out other equations or to derive other equations or to do some simple numericals. So let me go for the next level. So the next level, in the next level we will be considering that a body is moving with some initial velocity. That's now we have discussed about car, correct? We have discussed about the car, and the car was moving at point A with initial velocity u, and at point B we have found the car was moving at velocity v. So we'll plot this one as a graph. How we'll plot that one in graph? Just let us see now. This is the graph where this part is your time and this part is your velocity. So your x-axis gives your time. You need to remember, we always normally we plot time on the x-axis and velocity on the y-axis. So be clear on this and keep it is as your standard only, because if you change each and every time it will be problem for you to understand the higher concepts. Now if you draw what I said, that the body was at point A, where we have considered the velocity as how much? The velocity as how much? At point A, u was the initial velocity, correct? So let me consider the body at A. Say this is your point A. At this point velocity was u, remember this part. Now that means from here the body started moving. If I now draw, let me draw it in green only, as everything is green nowadays, so we need to have a green. Even the coronavirus is also green, correct? The virus color corona is also green as per the pics and all videos. I am not sure on that. I am not a doctor, not a scientist on that. So let us consider green only. Everything is green. So let us let us draw a green line. Now this is point A. So from here we have started plotting. At point A the velocity is u. At point A the velocity is u. Let me write in small u. And at point B the velocity is, if I plot this one here, velocity I am finding v. This is your point B. So the body was moving with respect to time, the body was moving. So that's your graph. At point A we have started plotting where the velocity is u, and at point B we have ended our reading of your velocity. Speedometer you can consider. For a car you can consider, or for a bike you can consider speedometer. So for the speedometer was seen to be showing you can take it as kilometer per hour, meter per second, whatever you want you can take it. For the time being we are considering kilometer per hour. Say u kilometer per hour it was moving initially, that was point A. At point B when it reached, we have found that the velocity is v, that's the final velocity. Now let us drop some perpendiculars and let this be the point O, or the origin of the graph. This is your point A, this is B. Let me write as this one as D, this one as C, and so we have got a figure, correct? In a graph we have got a certain figure. What we have got? We have got a triangle, we have got a rectangle. Now you need to understand this part. it's a velocity and time. Okay, this is u, that means if that is u, that means this portion is your u, this distance is u. I have written over here, if this is u, then this portion is also u, correct? The total portion from down to up, from here to, if it is v, that means from this portion to this portion is your v, from origin to this portion is your v. Then if I draw this one, then this is your v. If the total portion is your v, this is u, then what will be the length of db? What will be the length of d and b? This length will be how much? This length will be how much? This length will be your v, that is the total the total velocity, minus u, v minus u. Telling it again, this is u, that means this from origin to a is u, so this is u, that means this is u. The total portion from O to V is V, so that means this is V. Total is V, this is U, so this portion is V minus, so this portion is your V minus U. Hope you understood this part. If you cannot understand, rewind it and view it again. That's the only way, otherwise we can also communicate in our private WhatsApp groups. Now what we can do, now let us find out, say, let me find out from here we can find out the acceleration. Can we find out the acceleration? How we can find out the acceleration from here? Consider, say, this as, say, time t. This is your t, that means from 0 second, 0 hour to t hours. Okay, this I have also written as c, na? So let me write c over here and let me write t over here. So that means if I consider, say, acceleration means from this point to this point the velocity increased, velocity from a to b increased with respect to time, so that means that is acceleration. So acceleration I can write then this one, so that means this is the slope. If this is the slope, that means del y. What del y means? Difference in the y axis, that is v minus u, and difference in the x axis, and this one is how much? This t only, that means here del t is nothing but t, then that is t. So from here also we got the same equation, that v minus u equal to at, which will give us v equal to u plus at. So you got the equation from graph as well. Now let us find out the displacement then. How you will find out the displacement? Displacement is denoted by s. You need to remember, displacement is denoted by s, and that can be found out if I take this area, if I calculate this area and if I calculate this area, that means the summation of the areas under the graph, that means this portion, the area under the graph or under this line AB gives you the displacement within that time, that is from point A to point B when the car moved. The display under this graph is your displacement if I calculate the total area. Now if you see here, this is a triangle and this is a rectangle, so that means if I write now S is, that is the displacement, it is a summation of area of rectangle, what I can name it, OADC plus area of triangle, that's the triangle, that is ABD, so that is a triangle. So area of rectangle is simple, length into breadth, so length is how much? T, and breadth is u, this is u, so I can write u into t plus area of triangle, formula of area of triangle, half base into height, so you have half base into height, base in this triangle, which is the base? This is your base, that means t, base into height. What is height? V minus u is your height, v minus u. Let me put it in second bracket. So you got this one, this is your ut plus half t into t I am writing half t. V minus u, if you remember in the earlier, hope you have taken the notes from the board. Please copy the board. As soon as I complete, you pause at any position and copy the board and then go for the other part. Take this one as your class, as you are used to follow in your classroom sessions. Please take it in that way only. As soon as I complete one topic, pause the video and then copy it. Otherwise it will be a very much problem. Don't just see and just go just do other things, please. So hope you have copied that part. If you remember that part, I have written v minus u equal to at. Simple. From here only I can write. From here only I can find out v minus u equal to at. So t into at. So at into at. So how much you are getting? S equal to ut plus half at square. So that's the another important, most important equation. S equal to ut plus half at square. That's one of the most important equations over here. Now we have got the first equation. We have got the first equation as this one. This is your first equation. Second equation we have got this one. There is also a third equation which can be found out in two ways. Now let me find out in the most easiest way first. So this is your this one. I am rubbing it out. Hope you have already copied. Now then let us go for the third one. Now third one I can find out from this portion only. How? This equation 1, what I am doing? Squaring both sides. That means if I square v square equal to u plus at whole square, how much we will be getting? U square plus 2at u plus a square t square. If I do now u square, this is v square, I am writing v square over here again, u square plus, if I consider, say a is common, let me take 2a also common, so 2 also common, so 2a, if I take 2a out, you are left out with ut over here plus 2 I have taken common. That means obviously I need to have a half, then only 2 and this 2 will cancel out and you will be not getting anything. That means you will be getting 1 over here. If I multiply this one, 2 and 2 will get cancelled out and you will be getting 1. So to match up that part, since I have taken 2, that means obviously there is some half or 1 by 2 was there. And a I have already taken out, so only one single a remains and t square remains. So now v square equal to, you are getting how much? U square plus 2a, this portion is what? That's the second equation, s equal to ut plus half at square. So you have got S. So this is your third equation. So these are the three equations which will be very important for you. Now we have done with the third equation. This third equation can be also be found out from the graph also. How? Let me do that one also. But I'll prefer you go through this one, it will be much easier for you until unless they ask you to prove it graphically. If they ask you to prove it graphically, then you need to consider, then you need to take out or derive from the graph only, otherwise you will not get marks in exam. So now let me do it graphically. Again what I said, that displacement is this portion only under the graph. So again I am writing S and this one I am writing. How I can find out? I can easily find out by what is it? Is by finding out the area of trapezium. What is the trapezium? OA, B, C, O. OA, B, C, O. So this is your trapezium. Now formula of a trapezium: half into summation of the parallel sides into what? The height of the trapezium. Half into summation of the parallel sides. These and these are the parallel sides, OA and CB. So OA plus CB into, so summation of the parallel sides done. This CB and OA. This OA and CB. Half into this into height. Now if you see the trapezium, height is only this one only. This is your height. OC is your height. So let me write OC. So half OA. OA is how much? OA is U plus CB is how much? That is V. And what is OC? OC. What is OC? That is T. So this one I can write as half U plus V, or okay, let me write U plus V as V plus U. I think both are same. I think you will agree on that. U plus v and v plus u is same, so I'm not going for that part. So v plus u, I'm instead of u plus v, I'm writing v plus u. I'm telling why I'm writing this one. Now time t. What is t? From here only we have found out that the other part in the earlier board. What I have done from t, how I can find? Now this one is your half u plus at into t. This t can I find out from here then? From the value for formula only. So t, I am keeping it over here, v minus u by t. So t, I can write here v minus u by a. So now you understood that. That means why I have taken this one u plus v, I have taken as v plus u. Only thing to make you understand. If you don't interchange also, and if you can directly write here also, then your wish, no problem for that. V plus u into v minus u, that is v square minus u square. These formulas are very basic formulas, so please don't ask how you have got this one. Again, a square minus b square equal to a plus b minus a plus b into a minus b. So that only I have written v plus u into v minus u, that is v square minus u square by a. I have written s over here. Let me write s also over here. So this one I can write again as v square minus u square by 2a. Let me write here again that part. S equal to v square minus u square by 2a. This one gives you the formula as 2a is equal to v square minus u square. This one can be written as, finally can be written as, let me write over here as v square equal to u square plus 2as. So here you got the third equation again. So that means you can find out this third equation from this one directly, squaring both the sides. If it is not mentioned, that you need to find out graphically. If you are asked to find out graphically, simple, you need to use this one. There is no other way. If you are asked to find out graphically, you need to start from here. Remember one thing here. To find out the third equation from the graph, you need to use same s, but you need to take the area of the trapezium. At that time we will not consider triangle and rectangle separately. We will be taking the total figure as trapezium. That only you need to remember. Now you have just copied it. I think you have copied it. Now there is one suggestion. Take these classes as you used to take in your classroom sessions. That means each and every topic, as soon as I complete on board, please note it down. If you don't note it down, you will be in problem, because these are all your notes which will be helpful till your class 11, those who are thinking to take science in class 11. And if you don't take my advice, be sure, if you don't take the notes and all, be sure that you will repent on this. I am telling you repeatedly, as soon as I complete each and every topic, please make a note from the board and take it as your classroom session. If in classroom session, what happens? There are a lot of questions from your side comes. I also enjoy in classroom session much than my online classes. I am not happy with my online classes, because the only problem in online classes also, if you ask, sometimes I miss also, and sometimes also in a position that I am not being able to what to say, I am not being able to make it more lively. So it's a problem for online classes, but classroom sessions, but again it is also very important, taking into consideration the present scenario. So be careful, take the notes. After that, if you get any confusions, let me know. There are several ways how you can come to me, so please let me know, means how you can communicate to me. Communicate in that way, in any other way, and please do the numericals out of this part. From next class we will do some of the numericals from this part also, so then it will be much clear. Again, there are also some other parts from 1D motion where we need to discuss some graphs and all. So hope you have enjoyed. I have tried my level best to make it lively. You know that one online classes, it's a bit difficult to make it much lively as we used to do in classes and all. In classroom sessions is much lively. I also enjoy seeing your faces. You also enjoy hearing my jokes and all. So that's the way what we are going to do now. There is no other option. So take my advice, take the notes from the board, make a copy. That will be helpful for your class 9 final as well as for your higher class studies, and then do the numericals. No leaving numericals. Okay, fine. Thank you to all of you.